All right, welcome back. We're on the second day of 11.2, and we're going to put it all together for a two-sample t-test for the difference between the population means. And again, we talked about those conditions being met. We talked about finding the t-value. And again, the technology is going to be the way that you're going to want to do this. Good tech video, again, online that you want to take a look at. And again, we'll go through those in class and walk through those as well. But the results are just way more accurate if you do that. All right, so let's put it together here. Here we go. Does increasing the amount of calcium in our diet reduce blood pressure? Examination in a large sample of people revealed a relationship between calcium intake and blood pressure. Such observational studies do not establish causation. Researchers therefore designed a randomized comparative experiment. The subjects were 21 healthy men who volunteered to take part in the experiment. They were randomly assigned to two groups. 10 of the men received calcium supplement for 12 weeks, while the other group had a placebo. The experiment was double blind. All right, and the response variable is the decrease in systolic, that's the top number of blood pressure for a subject after 12 weeks in millimeters of mercury. An increase appears as a negative number. So here's the data that we have. Okay, so we have those numbers. Again, group 2 says one more, has 11, and group 1 has 10, it looks like. So there we go, we have the data. Now, do the data provide convincing evidence that a calcium supplement reduces blood pressure more than a placebo on average for subjects like the one in the study? And again, this is one where we're going to use our technology of our calculator. So let's state it. We're going to say that the average for calcium and minus the average or the mean for placebo, the population means. We're going to say that difference is 0, and of course the alternative is we're going to say that it's greater than. Okay, so that the mean was going to be greater for the calcium was going to be bigger than the placebo. So we're going to see that increase, or the decrease actually shows up as a greater than. So mu sub c is the true mean decrease in systolic blood pressure. So again, we're seeing that's kind of weird. You're seeing a number that's a decrease, but it's going to be positive. And the placebo is going to see the decrease in the systolic blood pressure. So we're going to use the significance level of 0.05. Let's get to the plan part. So we do a two-sample z-test for mu1 minus mu2. Random, there are 21 subjects were randomly assigned. Now, because our sample sizes are below 30, we're going to have to do dot plots of each of the calcium and placebo ones. And neither one shows any skewness or outliers. I think they're all pretty good. So I think we can move on from there. So the do part, now this is where I would put it in. And the nice part about it in the calculator is that you can actually put in the data. So you can go stat, edit, and then list 1, put the group 1, put those numbers in, and then list 2, put the placebo group in. And then what we're going to do is we're going to go stat, test. We're going to go down to number 4, which is a two-sample t-test. And some of the things that you'll have to put in is we're going to use data is what we're going to use, and then make sure that we're putting in L1 and L2 and that our frequency is 1, and then make sure to choose that mu sub 1 is greater than mu sub 2 when you put that in, and you're going to get the little more accurate results as we get those. I think we kind of show that too. So again, that gives us a p-value if you do that correctly on the calculator. 0.0644. All right. Now, using the table, because of this, we're going to get values between 0.05 and 0.10. So you can see, using the calculator, I'm going to promote that. It gives you a lot more accurate results, is what we're going to be talking about there. So I would definitely use that option. So we're going to conclude that because the p-value is 0.0644, that's bigger than our significance level of 0.05. So we're going to fail to reject it. We're saying that we do not have convincing evidence that the true mean decrease in systolic blood pressure is higher for men like these who take calcium as opposed to take a placebo. So, yeah, there it goes. All right, so if we're going to interpret that p-value, we got it there. So, assuming that the difference in the means is 0 is true, there's a 0.0644 probability of getting a difference between calcium and placebo in mean blood pressure reduction for the two groups of 5.273 or greater, just by the chance involved in the random assignment. That's what we're seeing. So that's the results. Okay, so again, using those as we say here, when we're getting to this, we're going to talk a little bit about the pooled idea. When you do that two sample z-test, if you have stats, if they give you the mean and standard deviations of those, yeah, you can use that. That's certainly something that would work out. If not, you can see those numbers as we get our t-scores and our p-value. Again, look at those. Always make sure if it's in scientific notation, like we had that one earlier, was there. And again, you can use data lists too. So the nice part is if you go to data instead of stats, those numbers that we listed in, list 1 is L1, list 2 is L2, frequency is 1 for each. Yeah, then we can use this as the greater than. Again, we'll go down to calculate, and it works out fantastic. Again, pooled, we're going to say no. Okay, we're going to talk about that in just a second. But again, you get your nice p-values. Again, 0.06, that's for the previous problem. Works out super slick on that and reduces that chance of making an error. All right, so again, use that calculator is what we're going to talk about there. Okay. All right. Now we did see that you had an option to go pooled. You might say, okay, what does that mean? Well, the unequal variance procedures use our formula, use the formula we talked about for the two samples t-test, interval and test. Now, the interval and the test are valid whether or not the population variances are equal, so that's fine. Now, the equal variance procedures assumes the two population distributions have the same variance. Now, this procedure combines the two sample variances, so that they talk about that as being pools it to estimate the common population variance. Now, the resulting statistic is called the pooled two sample t statistic, and the advice that they're giving us here is that never use the pool if you have technology that will do option 1. So just always put no for the pool is what we're kind of concluding there. Okay, so there we go. All right. Well, that takes us back, okay, to the end of this section, and we will pick this up next time. We'll finish up 11.2 and hence chapter 11. Until next time, I'm Mr. Wu.